Um, I would like to, call our panelists for today's discussion. So, Raymond Munnik, the CEO of Semco Smartech, and Dengyuan, CTO of Solar. So please switch on your cameras and also the microphones. So the topic of our executive panel for this first day of the conference is why the prime time for the TOPCon has come. And yes, the presentations we have seen today have given us many answers indeed. So this panel, in this panel, we want to discuss and analyze actually what we really learned. So so first, I would like to start with my one question that I've been trying to answer. So, things really took a real quick turn for the TOPCon. A year ago, when we did our previous high efficiency cell technologies conference, there was sufficient amount of ambiguity about whether what's really the next to PERC. So now, at least when looking at the size of the manufacturing projects that are realized and the company's announcements, TOPCon certainly seems to be well on its way to become kind of new mainstream. So let's first have some summary. So what are the key developments that have convinced the industry to move beyond PERC and towards TOPCon now? So, it's really drastic change. In early days of PV, to change a technology, it used to take a lot of time. But now it's really 1 year, things have changed so dramatically. But of course, there were things that were going in progress. So I would like to start with Dengyuan. Can you please shed light from your side?
Okay.
So do you want me to repeat the question?
Yes.
Okay, so, what really changed that the industry has really convinced that, okay, let's go to TOPCon. It happened just in a year, real in big volumes.
Okay. It's I think it's TOPCon is quickly replace get this market share increase. Then this is a perk. Is this marketing diamond? This is most important sense because this PERC solar cell is efficiency limitation is 23.5. Is some maybe is increased to 24%, but if continue increase much hard. So this marketing need this new technology is efficiency over 24%. So some three technology is should be can got it. Is one is TOPCon, is another one is heterojunction. Third one is IBC, can is over this 24%. But for this PV industry, important sense not is efficiency. This LCOE is cost is first, efficiency is second. Comparison, this is three technology. TOPCon is can compatible with this existing technology PERC, so much easy upgrade in low cost. Another one is in theory. This TOPCon technology have this is conservation contact technology can get its high room for efficiency. This is why is I think this is why is for this year, this is TOPCon solar cell. Efficiency is quite gross. Another important sense in China, all equipment and material localized. This push, this TOPCon solar cell is cost is down quickly. Okay.
So Raymond, what's your opinion? What's like this change 1 year? But of course, I know you have been a case for TOPCon from.
You have to give me a little bit more credit than 1 year.
Yeah, 1 year
you.
First of all, I would thanks again for having me in this panel. I would like to extend my special greetings to Dr. Song. We've not seen each other for a long time, so I'm really happy to see you again. Hello, Kevin. The key word, as mentioned by Dr. Song already, it's LCOE. I mean, at the end, industry is cost driven, and in investment wise, of course, it is. Can you deliver a better product for the customer? Basically, showing customer the advantages in this case of LCOE, and clearly, TOPCon has been the most, let's say, easy to integrate technology as the next basically successor of PERC, as I've been already preaching, let's say, a long time ago. And time-wise, I mean, you mentioned 1 year. This initially, of course, it was the industrially launched by us in 2015-16. By that time, too many steps and not cost effective. And also, we were not able to reach the right cell efficiency yet. So it was basically around 23%. What really has changed over the, let's say, the last 7 years that we are working on this technology, that especially from the improvement on the wafer materials, and also specifically thanks to Kevin and his colleagues, there have been lots of development on specifically the contact materials. And this in the last, let's say, 5 years, where the majority of the key vendors has been joining and creating or enabling higher cell efficiency, has made this possible. So of course, average cell efficiency difference is around at least 1.2 compared to % between PERC and TOPCon, and this was actually what is making the business case. And then it were basically the 2-3 companies like LONGi and Jinko, very silently, but on large scale preparing. And when big brands like this are stepping up such expansions as they are doing now, I mean, this is also the power of China, and then a lot of other companies can easily and fastly follow. And then last but not least, from my point of view, I mean, we have been there to initially teach, educate, enable, and making it possible based on basically our process and equipment. Technology, but the way this has been. The speed of which this has been picked up by these big companies, even for us, was remarkable. But this is also, of course, powered by the trend that was going on in industry, where basically there was a shift change on wafer size ongoing. So in the time where basically TOPCon was developed, this was the big basically discussion between M10 and M12 and even beyond, which is actually still ongoing. But right now, all capacity expansions had to be for different and new equipment anyway. So this has also kind of really opened the door to bring a new technology, which has been quite comparable to PERC from an equipment and also from a know-how point of view. And I think if you put all these parameters together, this is showing where we are with TOPCon now, and also as you've seen in the presentation I showed half an hour ago, why this TOPCon market will continue to grow so extensively, and I'm fully convinced of that.
Okay, so Kevin, already Raymond kind of pointed out towards you. So in your view, yes, of course, this would have not been possible without the developments from the paste vendors like you. So, but to exactly say in 2 words, what really changed in terms of pace, that kind of enabled this transition? The key developments in pace that really enable the manufacturers or gain their confidence.
Actually, for TOPCon solar cells, front side we need paste, rear side we need paste. The good thing is that for rear side, we can just modify the PERC front side silver. Then we can use it very well at TOPCon rear side. What we just need to do is develop all new silver aluminum paste for front side. That's a good thing.
Ah, okay. So, just still, I mean, heterojunction is still a hot topic out there. There are still some players who are pursuing it very seriously and with nice accomplishments and results. So what are the key competitive advantages of TOPCon over heterojunction from the technology? Whatever, I mean, in your view, each of you. Maybe Dengyuan, can you start?
Okay, it's a comparison with TOPCon and heterojunction solar cell. I think so. It's technology is always mature. Its problem is which one is can get cost down. Is just I just mentioned. Another one is the technology have this bottleneck or not. Is for heterojunction for last 2 years is much hot in this capital. It's market. Yeah, so it's you see, it's a lot of say this is next generation technology. For me, the opinions is for PV industry is much different. Another this industry like this is communication or automation like this one. Just PV is products, not cell, not module, is electricity. If use products is electricity, must be is comparison with existing technology produce electricity cost is the same. For example, in China, is a moment is called it produce its electricity is occupied is more than 60%. This is the cost is much low. So if renewable energy like PV and wind replacement, this cost, the electricity must be cheaper. This difference like our mobile phone. If a mobile phone combines new technology with this mobile phone can get more expensive. Somebody can buy it. But electricity is not. If say this electricity, for example, this efficiency can get is like gallium arsenide solar cell is 47% efficiency, but this is very expensive. Only use space satellite. Yeah, this is you can hard use. This is landing. This is why is PV industrial is different another industrial. So this is for all your question is for heterojunction with TOPCon is TOPCon is you say I just mentioned is have this suitable upgrade for high temperature technology. All is compatible with silver paste is can use high temperature silver paste, like Kevin just mentioned. Is if use this heterojunction must be use low temperature silver paste. Low temperature silver paste you use more, and another one is cost is high. This is the first is problem. Another for heterojunction bottleneck is this is capital cost. At moment in China, if you investment for 1 gigawatts TOPCon solar cell production line, 1 gigawatts only need 0.18 RMB. But if you heterojunction, this is a capital cost is double, is 0.4 is roughly like this one. This second is another one is N-type this wafer and the silver paste. So like this situation, in my opinion, this heterojunction is a good technology, but need this next is give this technology roadmap for reduce cost, have get this is more cheaper. Comparison this TOPCon maybe have this is a good future. Okay.
Okay. So I think you covered almost all the topics, but Raymond and Kevin, do you think you can add anything apart from that?
Actually, I just want to add something. We are zero-based suppliers, so I try to give you some numbers. We actually do some calculation for normalized silver consumption. For PERC right now is around 10 milligram per watt. For TOPCon is around 13 milligram per watt. But for HJT is around 22 milligram per watt. That it means a lot actually. This is from the metallization cost. And also Dr. Song mentioned that for TOPCon solar cells, we can leverage our expertise and experience on the development of high temperature zero paste that try to leverage to cover the needs of TOPCon solar cells. But if for the HJT solar cells, we have to design our new low temperature curing or sintering paste. This is that thing. I think the other thing we need to realize is that so far we cannot differentiate the efficiency between TOPCon and HJT. HJT right now has a higher capex cost and higher metallization cost, but if HJT can deliver much higher efficiency, that's quite good. It's also competitive, but right now the efficiency is actually almost the same level compared to TOPCon solar cells. This make this difficult in this competition.
Okay. Raymond, would you like to add anything, or shall I move?
Yeah, I think Dr. Song has been very, very complete, so difficult to add on top of that. Kevin is fully right, of course. Metallization costs, I've nicely illustrated that in the slide that I've shown from PV Infolink. So this gap is difficult to cover between the technologies. But I think fundamental understanding is quite important. Technology-wise, both cell concepts, heterojunction and TOPCon, are really, really nice. And when being as an engineer, you would be kind of you're tending more to look into heterojunction. As Dr. Song kindly explained, there's multiple drawbacks. Basically, when you want to invest into that from a business point of view, so you really need to be dedicated to do so. But commenting on the topic that Kevin mentioned, efficiency is, of course, it's important to have this gap. If you switch to the next technology, you need to have this cost gap. And TOPCon already, let me rephrase. Both technologies, TOPCon and heterojunction, are based on passivated contacts. But it needs to be understood that the cell efficiencies that have been kind of currently shown and mentioned. I mean, except from some record stuff that you see from the LONGis and the Jinkos, in mass production right now exceeding the 24.5 is without selective emitter, yeah, and this is with only the rear side passivated. I mean, the passivated contact on the rear.
On the rear side.
So it means on the front side there's no basically poly yet. So it means that even for TOPCon we still have the potential to put all that on the front and therefore bring the efficiency above 26%, as shown by the roadmap of Dr. Song. And so back to Kevin's statement. So right now, basically, average cell efficiencies of TOPCon and heterojunction are very similar. And I think that this year, when you will also see that in your conference, when you compare tomorrow's data with today, you will see that some of the TOPCon efficiencies already is outperforming heterojunction. So yeah, it will be a race between the two of the technologies, but at the end, the market will decide. And I think the graph that I've shown has been quite instrumental for us the last couple of years already. I think it's clearly that TOPCon is taking the lead in this challenge. But in function of creation of energy, it doesn't matter. There's enough market for both heterojunction and TOPCon. And last but not least, from the efficiency point of view, I mean, theoretically, the experts are telling me that the back contact TOPCon cell is, of course, a higher theoretic efficiency than the heterojunction cell. So this, with all this in mind, basically bridging it to future even tandem cells, we still see very strong lead the next couple of years for TOPCon. So for the moment, we will stay on our path, more successful path. Yeah, we're enjoying it, Shravan. Huh?
Sure. I can see that. So, coming to the main topic of the TOPCon, as I can see, at least from this conference, or in general, when I'm talking to companies, so to our understanding, the main topic of discussion right now for the TOPCon is about deposition technology, which is again, Raymond, your subject of expertise. So, which technology is going to be widely adapted? So LPCVD or PCVD? Because if you look back in the PERC, it was really ups and downs. So PCVD, then ALD, then PCVD, then combination. So do you think same gonna happen with TOPCon, or is it very clear to you?
Okay, if you want its mass production for TOPCon, you must be choice for polycristallite deposition tools for this LPCVD, PCVD, and the Smartech, another technology. For my opinions, every technology has this advantage and disadvantages. Is like our people. You must be balanced. Is which one you can benefit. In this stage, is in Solar is why use this LPCVD for TOPCon. It's because the first one is we studied this TOPCon solar cell from this 2018 is 4 years ago. We use LPCVD because LPCVD come from semiconductors. Semiconductor transistor is gate electric use this polycristallite. So this have a long history. This equipment is advantage is this reliable, robust, and batch uniformity is good. This cost is lower. So this why is Solar use LPCVD. Another one is because this is quality is good for polycristallite. Is because he can easily combine this small gross silicon oxide. This is two function in one tube is much easy. This small is deposition oxide is have a good quality than this plasma.
Okay.
So
Raymond, so one question to Raymond. So, you were doing LPCVD, so you were a strong proponent as of now. That's what I see from your presentation, but you might have also seen the presentation from Lead Macro, like, you have a PCVD, which has very high deposition rates, and you can do everything integrated, making your life easy. So what's lacking for a PCVD in your view?
What is lacking for what?
But for PCVD, because it comes with such a nice package. So why you are still convinced with LPCVD is going to be?
Actually, to be clear, from our side, is not what we are convinced at. Is just what we see that our customers are preferring to choose, which is, of course, as Dr. Song explained, this is the better control that you have basically with the LPCVD furnace, which has let's say a higher load. To give you an idea, LPCVD we load 1800 wafers, and for PCVD we load around 750 wafers. So it's a very big difference. Then of course you can really decide the crystallinity of the material. So you have the full range of control between polysilicon and amorphous silicon deposition. So it means you have therefore a more robust control of your process window. And as Dr. Song already mentioned, we grow the tunneling oxide in situ in the same step. So if you want to do that in a PCVD system, you have some challenges, because you need to play, because when you deposit it, of course, you're challenged by the uniformity. So you have to start playing with plasmas or with ALD processes, as are basically our friends from Lead Micro now are going to do. And what we see is that our customers, on one hand, are very much intrigued by it, and there's a lot of propaganda ongoing, wrap around and breaking tubes and all this kind of stuff, and things that we don't suffer from. So at the end, we see customers looking at reliability, then yield. I mean, it's very important to have the yield in the 97% range, as also previously mentioned. And this is done by LPCVD for many years already. So people are simply basically following that lead, and also the reactor volume in LPCVD is easier to grow. So it's easier to put larger wafer sizes inside there, because due to the lower pressure compared to LPCVD and PCVD, you have a better distribution of the precursors.
One question, Raymond, because I also saw your graph where you were comparing the cost for LPCVD, PCVD, and all the technologies. And of course, so when you say you don't have problems, but other LPCVDs do have problem, right? So have you also factored in the loss of the quartz, or whatever the problems they are getting from the quartz, factored into your cost calculations? Because you also mentioned LPCVD from others.
Yeah, and actually, in that others, we have not put in this initial quartz breakers. And what we also have not done is that we see others putting the wafer single in the slot, as I said in the presentation. So we're basically giving the benefits of the doubt, just looking at load size, cycle time, and consumption data that we have. So this is based on real data that we managed to get basically from our customers.
Okay, so I'll come to the single wafer processing next. But Kevin, from the metallization point of view, from the paste point of view, do you think there is a difference between these two layers? LPCVD, in situ, ex situ, then grown silicon oxide, deposited. There are several film configurations that are possible. So
it's a very difficult question to answer. It's good luck, Kevin.
I can try my best. For LPCVD type passivation tools, is high quality deposition. So it looks customer try to use alkaline polished surface to combine with the LPCVD machines. And if with the PECVD type machines, blister issue and adhesion issue still is a concern. So looks customers would like to use the small textured surface to combine with PECVD type of machine. So backside morphology always impacts the silver contact performance. So it's actually difficult for paste to contact alkaline polishing surface, but easy to contact the smaller texture surface. This is the difference from paste point of view. The other thing, I think we talk a lot about the advantages, disadvantages between LPCVD and the PECVD, but I think we may miss one thing is that if the industry would like to do the ultra thin polysilicon layer, this is one factor. The other thing, if we want to use poly fingers on the front side, that may make a great impact on which one is better. We need to think longer for the ultra thin polysilicon layer, and what will happen if we use polysilicon layer on the front side. What will happen? Which kind of machine will place better performance? That's my understanding for reference.
So still, do you see any difference in difficulty? So is it LPCVD is better than PECVD, or PECVD better than RPVD? What in one sentence? Or it's one and the same unit of
right now, at right now the polysilicon layer is just around 120 nanometer. Paste can work well with both kind of machine, but I'm not sure if we go to 60 nanometer, 80 nanometer, what will happen. I'm not sure because we do not have such data, but I think it will be different.
Okay. So again, going back to Dengyuan, so what do you think about loading single wafer per slot? Some companies are trying to do with LPCVD. So what's your opinion there?
But this is for wafer is because at the moment we use 140 micrometer thickness. Because this is for this year and the last year, this silicon fit torque is cost going is quickly. Must be decrease this silicon wafer for N-type silicon wafer cost. Because this way comparison with the PERC solar cell, this wafer thickness is thinner than PERC is 10 micrometer. PERC is normally at the moment use 150 micrometer. We try to get thinner and thinner. We try at the moment is 135 micrometer. Because it's a good automation in the tools. This not is much difference is with 140. For my roadmap for wafer thickness, maybe the 2025 can get TOPCon solar cell is wafer thickness is this decrease to 120 micrometer. This for this probably should be in this. For this is soldering. For this is make this module soldering. If you say this soldering, if this two thinner should be breakage is rate is high. This dependent we collaboration with this soldering machine is company is can get is salt contact soldering. Is can get is suitable is more thinner this wafer. Yeah, I think is if get is lower LCOE, wafer thickness is must be the decrease is in next few years. Okay. I can say,
LONGi, you are mute.
yeah, you mute.
Oh, sorry. So no, my question was different, but you know, your answer did address one of the important questions that I was going to pose next time. But no, I think that's great. So Raymond, what's your opinion about doing single wafer processing in LPCVD, for example? You know, some companies are trying to do so. If the equipment is not expensive enough, you can have double the amount and you can do it. So, you know, this is also happened with half wafer. When the CTS, the stringing tools were so cheap, you can simply move to the half wafer and you can do it, right? So, Raymond, what do you think what do you think about the approach of doing single wafer per slot?
I mean, first of all, I mean, I don't want to debate economic laws with you, but I mean, the best tool, of course, is a tool that you don't need to buy, you don't need to install, you don't need to create factory space floor, and you don't need to operate, and you don't need to maintain. So, yeah, to say that we can do like this and just we buy double the amount of tools and those, I mean, whatever you do, I mean, those tools are LPCVD equipment, and there is only a cost down possible up to a certain level. So they're expensive machines. It's not like a stringer. So I think I would really encourage our customers basically to, I mean, we love the POs, but to use them cost effectively. So our philosophy is simple. I mean, in principle, for the current basic TOPCon technology, we need the poly only on the rear. That's what the majority of customers is doing. So we try, with this respect, to put as many wafers inside the reactor, because at the end, the other side is etched later, as you know. I think why other people are doing it single side slotted is because they don't know how to design the LPCVD equipment well. This is one. And then secondly, they're also struggling with how to remove the parasitic deposition. And this is where LPCVD is kind of nice, because you can really design the crystallinity of the material the way it can be etched well. And if you then position the wafers right in your reactor, you can do it what we do back to back for baseline process. So of course, for more advanced cells structures like IBC, it could be beneficial to start differently and have back on double-sided deposition, but it really depends on your process flow chart. What is important from us, and this is what I try to highlight with our presentation today, that our machines have the flexibility, and you don't need to swap or exchange them. They can do both. So at the end, we see that our customers making decisions mainly on economics, and then of course looking at matureness, which is a lot yield and process robustness. And this is where, if you like it or not, LPCVD still comes in place. PCVD is definitely gaining popularity, but this is also still possible now because let's say my customers are creating a lot of additional premium revenue, because also heterojunction now and TOPCon modules are because they are still the capacity is still under 100, available under 100 gigawatts, so pricing is still high. And what will be interesting to see in the next couple of years is when, let's say, the available module capacity will be above 100 giga. What then are the most preferred ways of manufacturing based TOPCon cell? Because then I think that this whole discussion between LPCVD and PCVD has already been matured. For the moment, we can do both. But back to your fundamental question, I mean, what is really necessary to make to enable the success of the PCVD is, of course, to integrate the tungsten oxide, and this is a challenge. Has been showing by the team from Lead Micro that basically just had success with the first pilot line, and we know. I mean, we've been doing this for 5-6 years, so we know how tough that job is. And let's see if this technology can mature, but it might go into straight basic PCVD from there, without any let's say, tricks as just previous show. We think it can be, can be solved in a very solid way. But for the moment, LPCVD remains the baseline for the majority of the people that at least we know.
Okay, of course, there are really tons of questions, and then I think the discussion can go endless, but still we have to keep the time in sense. So, I would like to ask one final question. So what's the most important next task for each of you to support and speed up the transition to TOPCon?
Okay, it's for this TOPCon is, I think, is still have this efficiency is increase for this few years. Is they from the theory of calculation can get is this limitation is 28.7 for double side TOPCon structure. If one side should be limitation in theory is 27.5. So I think it's a two-way. If for my opinion, is TOPCon is should be mass production can get our 26 percentage efficiency. This is no problem. It should be next 2 year. This if our is 26 percentage, should be is much hard. Use this is double side is TOPCon structure, or this is real side junction. If our 27% efficiency, I think use this structure is for single junction is very, very hard. Should be is use this like a tandem solar cell, use this bottom cell, use TOPCon heterojunction is front side cell, use persicate or some others, this thin film solar cell. Should be it's break through this silicon single junction silicon solar cell efficiency limitation is 29.4%. Some experiment results for persicate plus silicon can get 31.4 efficiency.
Okay. So Raymond, what do you think? What's your next step, immediate next step towards the TOPCon?
Immediate time.
No, sorry. This question is to Raymond.
Okay.
Raymond.
I mean, there's basically two trends. So one is increase of course of cell efficiency, which is related to bringing also the poly to the front. So I think this is the next industrialization trend. So in between, there's a lot of work still to do on the boron emitters. I mean, also more advanced contact materials will be coming up. So here, this is a big dance still to be completed. And then we see another basically interesting globalization trend that outside China, multiple countries are basically entering PV manufacturing, and we are quite instrumental all the way from the US to India to Arabia, and also in Europe. I mean, in France, we have our own initiative for a 5 gigawatt factory called Carbon. So I'm quite looking forward to that, to bring all the know-how and expertise that we gained from our Asian customers, and to bring it to rest of the world, and see how we can get all these factories running, above 25% cell efficiency on the gigawatt level. So the world is changing, and it's it's a new era in my career, and I'm looking actually kind of forward to that. Yeah?
Great. All the very best. Kevin, you are on mute.
Okay. Actually, I think also first one is efficiency. You know, right now we can work with customers to achieve more than 25% solar cell efficiency with the conventional emitter. If combined with the selective emitter, we can further deliver more than 0.2 or 0.3% efficiency gain. So we are positive to achieve more than 25.5% efficiency next year. And if combined with other process optimization, I think 2026 is achievable. This is for efficiency. The other one is cost. Always metallization cost is a concern for the bifacial solar cells for TOPCon. You know, as I shared before, for PERC is 10 milligram per watt. For TOPCon right now is 30 milligram per watt. But we are quite positive to achieve the equal metallization cost between TOPCon and PERC early next year. And we have some confident methods. First, we can use ultra fine line printing. You know, right now for PERC, the finger opening is less than 13 micron. But for TOPCon first side, 15 micron, rear side 18 micron. That's a lot of room for us to do it. So we are quite positive. Based on such progress, we definitely will achieve equal metallization cost between PERC and TOPCon and PERC. That will give a lot of advantage for TOPCon solar cells. That's actually the immediate actions what we are doing right now.
Great. I think that's really a nice closing remark, that a possible 26% efficiency with reasonable cost for TOPCon. That's great. So with this, I would like to hand over it to Michael to close the conference. Thank you very much, everyone. Kevin, Raymond, and Dengyuan, thanks a lot for your deep insights.
Shravan, thanks a lot for having us and for putting all the efforts in organizing this wonderful conference. Appreciate it.
Thank you.
Yeah, thank you.
Thank you.
Okay.